All right, so now we're moving on to slightly harder examples. We're still rationalizing the denominator of radical expressions, but here we have 1 over the cube root of 5. Kind of unusual, but we can still use the exact same technique. However, instead of canceling a square root, we need to worry about canceling a third root in the denominator. And we're going to use a very similar trick that we've done in the past. So, how do we do it? Start with our expression. We have 1 over the cube root of 5. Can't break down 5 any, so what we're going to do is we're going to cleverly multiply by 1, but it's a different type of 1 this time. So we have the same denominator, but this time we're going to square it. So what we're going to have is 3 root, cube root of 5 squared. And you'll see why we did this in a second, and I'll illustrate. So we have cube root of 5 squared in the denominator here. Okay, so now multiplying across, I get cube root of 5 squared in the numerator, and then the denominator, I'm going to combine these because now I'm multiplying straight across the denominator. So if I have the same radical here, I have cube root and a cube root being multiplied together, I can use the product rule for radicals so that I get one big radical. So I have a cube root of 5 times 5 squared. Now you can probably see why I used that squared as opposed to just using the original denominator, because now that I have this squared and this extra 5, I have 5 cubed. And that will cancel off the cube root here. So I have cube root in the numerator of 5 squared over the cube root of 5 cubed. Okay? Continuing along, I have cube root of 5 squared over just 5, because I canceled off the cube and the cube root. So this is all I have left. I cannot simplify the top anymore because I have a cube root and of a 5 squared. So I don't have enough 5s to cancel off the cube root. So with this, we are completely done. All we needed to do, to recap, is we multiplied top and bottom by the same denominator, but we added an extra 5 inside the radical so we get cancellation later. That was the goal, and that got rid of the radical in the denominator. Okay, so with that, we are done. If this video was helpful, please like and subscribe, and check out more videos on projectgradered.com.